Okay, so in this video, I'm going to create an AWS environment that you will use to run Linux machines. So in this class, we're going to run a lot of Linux machines, and we're going to see how we can configure them both system-wise on the instance itself, and also how we can create infrastructure in an automated way. The first step is to create a couple of components. We're going to use AWS for these components. That makes it easier rather than running virtual machines on your own laptops. So I'm going to use AWS throughout the course. You are free to use another cloud provider, especially for the first few classes. But for the time being, this is going to be the infrastructure we are going to work with. So in AWS, basically you have a VPC, which is your own little slice of cloud. And inside that VPC, you can create a bunch of components. And the one that we're going to be interested in the first few classes is the instance itself, the machine. And we are going to run Linux on that machine. And we are going to script automated installations to start with. And then we will use Ansible to do a lot of automated operations. So the objective for this first week is to basically have access to a Linux machine running on AWS. So you're probably very familiar with AWS thanks to your cloud course from term 3. But I'm going to walk you through all the steps that are required in order to make that happen in your on your own AWS account. So obviously you will need to have your AWS account set up and to have credits on it so that you can run components. Some of these components require credits, so you'll have to pay for them. You can expect to pay a couple dollars every week tops. Make sure that you turn off all your AWS components when you're done working with them so that you are not charged for them for nothing. So that's my AWS dashboard. My account is set up. I have credits on it. Some of these credits are actually free credits that I got from AWS thanks to the AWS Educate program. You can also have a look. Maybe you're eligible for them. But basically, from this dashboard, I have access to anything I want on AWS. And I'm going to start creating all these components that you see in this drawing here. So we'll create the VPC first on the dashboard. So you'll have to browse to the VPC dashboard if that was not already the case for you. And on that page, you can see that you have access to your VPCs. So you may have other VPCs that already exist because you created them and worked on AWS in other classes. We are going to create our own VPC to work on machines in this class. So we are going to click on the Create VPC button, and then you will have access to a bunch of web widgets that will help you create your VPC. So I'm going to use sort of a naming scheme throughout this class. My VPC here is going to be called ACIT4640 underscore VPC, and basically I'm going to use ACIT4640 as the prefix for all the components I'm going to create in order to make them easy to find on my dashboard. So my VPC is going to be my own private slice of cloud that I can basically do whatever I want with. And I will need to provide a range of IP addresses that I can use on my VPC. You can choose pretty much any kind of IP addresses you'd like. These IP addresses will be private, so they will be compliant to RFC 1918 addresses, which are basically these ones: 10, 172.16 and 192.168. So these IP addresses, as you probably know, are private IP addresses, and they cannot be routed on the internet. So they are good for internal networks, private networks. And this is what we're going to use on AWS here, because our VPC is going to be a private bit of the cloud with private IP addresses. I selected sort of a random range of IP addresses. Here you can choose whatever you see fit. 942 is the answer to everything, so I'm going to use that as my CIDR block for my VPC. We are not going to deal with IPv6, so I can leave that empty. And something that's very important to remember on AWS, there is a lot of things that are actually labeled with tags. And a lot of AWS components don't really have names, they have tags. And one of these tags can be a name tag. So here, my VPC actually got its name from the name tag on my resource. So once I've checked all the input, I can create my VPC. And now I have information on my dashboard that my VPC is created. And I have a private range of IP addresses available for me to use. So that was the first step. The VPC is this big box here on the drawing. And now we are going to create the components inside the VPC. So something that I forgot to mention is that everything in AWS is tied to a region. And the region that we are going to use ourselves is US West 2. You can use any region that you like, but obviously you should use an AWS region that is close to where you are. In our case, because we're in BC, the closest region is Oregon. US West 2, you may use US West 1 as well, but US West 2 is usually a good choice. So my VPC resides in US West 2. That's my region, and that's my range of private IP addresses. So the next step is going to create my subnet inside my VPC. So this is nicely laid out here, and now I can create a subnet to host my EC2 instances in my VPC. So it's the same story. I'm going to use the create subnet button. And here, something that's very important is that a subnet is sitting inside a VPC. So when I create my subnet, I need to select the VPC that I created earlier. So this is the VPC that I just created, AC804640 VPC. I can give my subnet a name. So I use the same naming convention with the prefix. And here, and this is very much AWS related, I can choose an availability zone for my subnet. So in a region, in AWS, you have several availability zones. Each of them is kind of independent from one another. So that allows you to set up high availability services and disaster recovery procedures in case anything happens on your on one of your availability zones. We are not going to deal with that. We are just going to work within one availability zone. There are some specificities regarding AZs in AWS. Some of them don't have all the services that we're going to need. So in US West 2, you can safely choose 2A or 2B, and you will be fine. I'm going to choose 2A here because that's the first choice that I have. And my subnet is going to have an IP range as well. This IP range needs to be within the IP range of my VPC, obviously. So I'm going to choose a range here. I chose 10. This looks like a sensible choice, so I'm going to keep that going. And as you can see, I'm using /24 here. My VPC is /16, and my subnet is /24, which is enclosed within my /16 VPC CIDR range. Same story here. My subnet has a tag called name, which gives it its name. And yeah, we can just go ahead and create the subnet. And now my subnet has been created and it's available here in my list. And I can see that it's connected or related to the VPC that I created earlier. That's good stuff. I created my VPC, I created my subnet. now my machines are going to need access to the internet. In order for that to work, in AWS, you need to create a component called an internet gateway. So let's do that. That's conveniently located just on the left here. And I'm going to click on the button and click create my internet gateway. I'm using the same naming convention as always, 4640 IGW for internet gateway, and I can just go ahead and create it. And my gateway is now available in the list. So here, there's something interesting going on. My gateway has been created, but it's not tied to my VPC yet. As you can see, it's in a detached state, and it doesn't have a VPC ID linked to it. So one of the things I can do is attach it to my VPC. Here in the list, I can select the VPC that I created earlier in the first step. So that is going to actually tie my internet gateway to my AWS VPC, effectively achieving this in the drawing where my internet gateway is connected to my VPC. All right, now it's attached, it's green, that's good, and it has a VPC ID tied to my gateway. What else do we need? We need a router. Our traffic is going to flow in and out of our subnet, and it's going to go to the internet and back eventually. So in order to manage that, we'll need to use a router. Routers on AWS are actually called routing tables. And there is usually a main routing table that is created with your VPC and is eventually with your subnets. This is the default routing table, and basically I prefer to create my own routing table, which is not the main routing table created with the VPC, and I usually call it RTBL for routing table. And I can connect that routing table to my VPC, and that will allow me to route traffic inside my VPC and between my VPC components. So to create that routing table. And now I have something interesting. So if I go back to the routing tables, the list of routing tables, you can see that the one that I had before, the main routing table, is still there. I don't want to touch it. I'm going to deal with that one, the one that I just created, which is not the main one. And I can click on it and then make a couple of interesting changes to it. So the first thing that I'm going to do here is that you can see that my VPC network range is known to my router, my routing table. What I want to do now is make sure that this routing table knows how to deal with traffic from the subnet that I created earlier. So that happens in the subnet associations tab, which I'm going to click on. And here you can have, well, you can see your subnets. These subnets have not been explicitly associated with any routing tables, and as such, they are associated with the main routing table. So this is not something that we want. We don't want to be default or not explicit. We are going to edit the subnet associations and make them explicit and connect our subnet to this routing table. So I clicked on the edit subnet associations on the subnet page, and now I can connect my subnet to my routing table. I'm going to save these associations, and now I see an explicit subnet association in that routing table that well, relates to the subnet that I created earlier. But that's good. I have subnet connectivity. Now, the thing is that whenever traffic is going to hit my routing table, it needs to go out on the internet if need be. And that is not happening yet because my routing table only know the destination 10.42, which is my VPC network range. So I need to edit my routes and add a default route that will catch traffic going to the internet and send that traffic to my internet gateway. So in my routing table page, I'm going to edit my route. This is the route to the VPC, which has a local target. I'm going to add a new route. And thanks to your networking classes from previous terms, you know that the default route that will catch any traffic is with destination 0.0.0.0/0, meaning basically everything. And this traffic is going to be sent to the internet gateway that we created earlier, which is here. And it shows me now the list of gateways that I have available in my VPC. I just have one, so I'm going to select it. And this is going to be the route that is going to allow traffic coming from my subnet to flow to the internet. So I can save my changes here. Now I have my routes with my subnets and everything set up for my machines. We have a couple of things that we still need to set up. We have the VPC, we have the subnet in our AZ, we have a router, and we have an internet gateway. We are going to create an EC2 instance very soon. These EC2 instances, their traffic is filtered by two kinds of components on AWS, at least. We have security groups and we have network ACLs. So you may have seen how to manage a firewall in your networking classes in previous terms, directly on the virtual machine or on the machine. We don't do that very much in the cloud. We delegate the filtering of traffic to the cloud provider. And in our case, an AWS, filtering in and out of an instance is usually done with a security group. If you want to filter the traffic in and out of a subnet, you will use a network ACL. In our case here, we are not going to use network ACLs. We are not going to do subnet filtering rules. We are just going to deal with security rules related to the instance itself. So we are going to create that security group here in order to be able to access our instance data. So in the VPC, now we can go to security. You have network ACLs and you have security groups. As I said, I'm not going to deal with the network ACL. There is a default one here that basically allows traffic in and out of the subnet, which is good enough for us. So I'm going to manage my security group. I have a default security group here. As always, I'd rather create my own security group. And here, I'm going to give it a nice, sensible name, and I'm using the same prefix that I used before. This security group is going to filter the traffic in and out of the instance. It's always a good idea to explain what this security group is going to do. What we're going to work with in this class is automated provisioning and setup on a Linux target host. These use SSH. So we are going to use SSH a lot. So the SSH runs on port 22. So this traffic is going to have to be allowed on the instance. We are also going to set up web apps, just as examples of things we can provision. And web apps use HTTP on port 80. So basically, we are going to open both of these ports because we are going to run a web service, a web app. I'm going to open port 80 for basically everyone. And then you have a question of security. How do you want and who do you want to access, who do you want to give access to your instance using SSH? That is a complicated question that is not covered in this class because it relates to network security and whatnot. It's always a good idea to restrict SSH access to administrative workstations or networks. In this particular example, I'm going to allow SSH for everyone on the internet, which is not a good practice in production. It's just gonna make my life easier in the long run, because now we are kind of half online, half in person. So when you'll be at BCIT, you'll have a different IP address than when you'll be working from home. So in order to mitigate all these problems, I'm going to basically open SSH to every host on the internet. So this is not something that you should do. You should think about that and maybe filter, add your own home IP address to it, and the BCIT range, etc., etc. We can talk about it in the next class. So I'm going to allow SSH and HTTP traffic to instances without typos. And I'm going to look at the rules, outbound rules. This is traffic coming out of the instance. Everything is allowed, so that's good. Outbound traffic is usually not restricted that much. Inbound rules, we don't have any rules, so we cannot do anything connect to the instance. So we are going to add a couple of rules. Here there is a couple of nice pre-made rules here. You can choose SSH in the list. It gives you port 22 because SSH runs on 22. And this is where I'm going to use something that is not good security-wise. I'm going to allow SSH access from anywhere. And I'm going to do the same with HTTP. As I said, we are going to run web services and web apps. So I'm going to also allow HTTP traffic from anywhere. It's different from SSH. HTTP is your public service, the one that you want to run on the machine. So it's okay to make it available to everyone. We have a name, we have a description. We can create a security group with our rules. Excellent. So we have created all this infrastructure. We have our VPC, we have our subnet, we have a security group, we have a router to route traffic, and we have an internet gateway that we can use to send traffic to the internet. So now all the VPC part is set up. This is something that you basically do once, usually, because once your VPC is set up, you can create as many instances as you want inside the VPC or inside your subnets. And instances are more disposable. You can create and delete them as much as you want. The good thing about the VPC on AWS is also that you don't pay for anything. So you can basically leave your VPC up or created on your dashboard, as long as you don't use an elastic IP not associated to an instance, or as long as you don't run an EC2 instance, you won't get charged for any of the things that we've just created. So you can leave them on in your AWS dashboard. All right, so that concludes the first part. And now I'm going to pause the recording, and I'm going to switch over to the creation of the EC2 instance. All right, so we have created the VPC and everything else inside. Now we are going to create the EC2 instance and actually run the Linux machine and connect to it from our computer. So this VPC was the infrastructure allowing us to host instances and machines. When you want to create an actual instance on AWS, that happens in the EC2 area, Elastic Cloud area. And here you have a list of all the instances that are running in your region. So once again, your EC2 dashboard will be tied to a region. The only thing that we have to do here is to create an instance, and there is a very nice web wizard on the AWS dashboard that allows you to do that. However, something that's important to remember is that your instance is going to run the Linux operating system of our choice, and we will need credentials, user passwords, whatever, to connect to that instance and work on it most of the time. This is kind of a complicated topic, but in our case, we're going to use templates, virtual machine images that have a lot of processes set up in order to create a user account that we can use to connect to that newly installed or created Linux machine. Logging in with a user and a password is something that is usually not regarded as very secure, and it's also complicated to deal with automation because it basically requires input to type in the password. What we're going to work on in this class is a lot about automation. So we want to make sure that we can basically connect to a remote target, a remote machine, using some kind of credentials without having to type in a password. And this is where SSH keys are coming into play. I'm going to talk a lot more about that in the next class. But basically, thanks to SSH keys, you can connect using SSH without typing a password. Your authentication is being dealt with using cryptographic encryption, and you have two things to authenticate on the remote target. You have a private key and a public key. Basically, the remote target knows your public key, and because you're the only one to have the private key, you're the only one that can prove that you have the right private key that matches the public key. From the public key, you cannot find the private key. So this is how SSH keys work. In a sort of very summarized way, using SSH keys, you don't have to use passwords anymore. Your password becomes your private key. And as long as the remote target knows your public key, which is very easy to find from the private key, you can connect to that public remote target. The other way around is really hard. If you have the public key, it's almost impossible to find the private key, meaning that you can give your public key to everyone. As long as you don't give them your private key, you can connect to these machines, but nobody can know your password, know your private key. So this is the mechanism that we are going to use here on AWS. And AWS allows you to automatically manage and create SSH key pairs and install them on the instances that you are going to create. So that's going to be our first step. On my website here, it's probably not done in, yeah, you can also do it from within the wizard. I'd rather do it in a separate step. So I'm going to go and click on key pairs here on my EC2 dashboard. So once again, this is the EC2 dashboard. And down here on the left, I have my key pairs. I already have one here. I use Terraform for other stuff. So I have my Terraform key. I can create a new key pair. And this is the SSH key pair that we are going to use throughout this class to connect to your Linux instances. So I'm going to create key pair button. And here I'm going to use ACIT 4640. The RSA key pair is good enough, and we rather use .pem format or use with OpenSSH. So basically, when I click on the button here, create key pair, AWS is going to create a pair of SSH keys. It's going to keep the public key so that it can install it on any instance that they create. And it's going to give me the private key, and it's only going to give it to me once because it's like my password. So it's not kept on AWS, and I only have it once. So I need to store it and make sure that I don't lose it, because if I lose it, I cannot find it back, and I will lose access to all my instances using this key pair. So I'm just going to create it now. And you can see that it's been created here in the list. I have a new key pair, but very importantly, my browser downloaded a file, which is my private key. And this is the file that you shouldn't lose. So make sure that after you downloaded it, you go into your files and you save it and you put it somewhere nice so that you can use it over and over again to connect to your instances. So that's the first start. Create your SSH key pair and download the private key and make sure that you don't lose it and you know where it is. Once you've done that, you can come back to your EC2 dashboard and you can click on the instances tab link. And then you have access to the wizard that allows you to launch AWS instances. I'm going to do that now. Launch an instance. And the first thing that I'm going to be asked is the template or the image that I want to use to create my instance. We want to use Ubuntu Linux because that's pretty good distribution to use. So we can go ahead and type Ubuntu here in the list. And this is also here. You can select this AMI in the list, 20 Ubuntu 20 LTS HVM. So that's the one. So I'm going to select that one, meaning that when I'm going to create my instance, it's going to run Ubuntu Linux 20. The next part is creating your instance and selecting the capabilities of the instance that you want to create. When you have free credits, T2.micro is usually available. So that's a good option. Depending on the applications we're going to build and run, you might need a little bit more than 1 gig of RAM. But for the time being, T2.micro should be good enough for our needs. The cost is also quite low, so it shouldn't cost you too much money to run these kind of instances. So I'm going to select T2.micro, and I'm going to click next. So I want to create one instance here. I want to make sure that I'm going to create that instance in the VPC that I created earlier. And here I'm going to set this machine up in the subnet that I created earlier. And this is where information collide with my materials, depending on how you create your AWS instance. You want your virtual machine to be accessible from the internet. You want to connect to it. You want to have a web service running on it that people can see. So you want this machine to be on the internet. In order to be accessible from the internet, this machine needs a public IP address. So you can either create an elastic IP and associate it with your instance every time you want, or in the wizard, you can also select enable to auto-assign a public IP address to that instance, which will basically make it accessible from the internet as long as your security group rules allow it. So I'm going to select that option, which means that I won't have to create an elastic IP manually. That's going to be done as part of the process. Most of the other settings are usually good. You can leave them like they are. Yeah. Oh yeah, that's good. Storage so that the hard disk of your Linux instance, we are not going to do much on the instances, so you can select a low amount of disk. 8-10 gig is usually good enough. I believe that you have 30 gigs of disk available for free as part of your instance reservation credits. So, well, that's something. So in my case, I'm just going to use 8 gig for my disk. So I can add a couple of tags. So I'm going to add a name tag because that's going to be nice to look at in the dashboard. And I'm going to call this my ACIT 4640 EC2. And well, I don't have any other tags to use at the moment. So I'm going to click next. And here, this is the security group. So once again, we are in the process of creating the instance. We are going to associate that instance with the security group that we created earlier. So here we can create a new security group, which is not required because we already created it earlier. So we can select an existing security group, and because it's conveniently named ACIT 4640, I know that this is the one that I want to use, and it has HTTP and SSH available. So now we are basically done. We can click review and launch, and then it will tell us what we are going to do. It will remind you that this instance is basically open to the world, which is not a good practice in terms of security. You can discuss that in your security class, or we can discuss it in class, or you can select finer control. You can use finer control on your SSH connectivity to the outside world. All right, let's click launch. As soon as I click launch, AWS is going to ask me about the SSH key that I would like to use on my instance. I could create a new key pair, but that would not be a good idea because I already created one. So I'm going to choose an existing key pair, and here I'm going to use the key that I created earlier. AWS is asking you to make sure that you have that key. It's downloaded here on my computer, so I know that I have it. And now I can launch my instance. From that moment, you are being charged. So your instance is going to stop running, and AWS is going to count the time that your instance is running. It's going to charge your account for it. So make sure that you work with your instance, and when you're done with your instance, you can delete it, which will stop AWS from charging your account. All right, so my instance is starting up. I'm going to change my screen sharing and move on to connecting to that instance using SSH. All right, so while the instance is booting up, I moved to my WSL terminal. So this is my Windows subsystem for Linux, basically my Linux environment in my Windows operating system. You have instructions on how to install it, and you can also get access to your Windows files from this environment. I created a new folder in my home folder of my WSL environment, which is called AWS Demo 1. And what I'm going to do now is copy the private key that was downloaded earlier from an AWS dashboard and put it in that very folder that I'm looking at right now. I created a symbolic link in WSL in my home folder /Windows, and it actually goes to my Windows folders, my home folders in Windows, where I have my downloads. So this is actually my Windows files, not my WSL files. And in this folder, I have the SSH key that I downloaded from AWS earlier. Because I did that a couple of times, I actually have this key duplicate, so it has one on it. But I'm going to copy it using CP, and I'm going to copy it to the current folder. And I'm going to use the name ACIT4640_key.pen. So that's going to copy the file from my Windows files into my WSL files in the very folder that I'm located in. And as you can see now, I have my SSH key in the current folder. And I can use it to connect through SSH on to my instance. So the problem that you sometimes have with WSL is that when you copy files over from your Windows directories or your Windows folders, sometimes they have the wrong permissions. So here I failed because I already fixed the permissions before I recorded the video. but you may have something like this, where your private key has all read and write permissions for everyone. So you will see that this is going to be a problem because SSH is not going to let you use it. So I want to highlight this. This is very important. You'll need to be able to set the permissions on your private key file in WSL. This usually means that you should not use files that are managed by Windows. You should use files in your home folder in your WSL files and not on your Windows partition. And you will see why a little bit later. So this is my private key, downloaded from AWS. My instance is now up and running. And I'm going to connect using that key to my instance. So here I actually need to switch back to my other screen. This one. This is the instance that I just created earlier. And as you can see, it has an IP address, a public IP address. This is a public IP that I can route on the internet. This is the private IP of the instance in the VPC. So basically, this is where you are going to connect in order to access your EC2 instance. So let's go ahead and do that. This is the IP address. I'm going to copy it into my clipboard, and then I'm going to switch back to my terminal, which is here. Yes. And I'm going to connect using SSH. So the first thing, well, you use SSH and you want to specify the private key that you want to use. So the private key is actually called an identity in SSH. So you use the flag -i to specify which file you want to use as the private key for the connection that you are going to deal with. So here I'm going to use the private key that I created earlier. Okay, now when we created the instance, we used an Amazon machine image that installed Ubuntu on our instance. And we created the instance and linked it to the SSH key pair that I used here. So in order now to connect, this is done automatically by AWS in the image. We need a user. And this user that was automatically created by the virtual machine image is Ubuntu, because this is a Ubuntu operating system. So this is going to be the username, the login name that we're going to use on our AWS instance. And this is going to be the IP address of the instance. So basically now we are going to, telling the terminal to create an SSH connection using ACIT4640 key as the private key to the IP address that's after the @ using the user Ubuntu. And this is what I was talking about earlier. If your permissions are not correct on your private key, SSH is going to complain and is going to tell you that you shouldn't have such open permissions on your private key. In order to fix that, you can use chmod, and you want to make sure that no one else but you can see your private key. So 600 is usually a good permission set. And if you look at your permissions again, you can see the difference here. We used to have all kinds of stuff, and now we just have read and write for the owner of the file, which is myself, and anyone else doesn't have any permissions to connect to use that file. Sorry. Now we can use the command again, and we can connect to your EC2 instance. So this is actually the EC2 instance that is running on Amazon. And because I made a couple of attempts before recording this video and it's still not really great. Something that you might encounter when doing SSH to your instance for the first time is this. You will connect and SSH is going to tell you that it doesn't know anything about the target you're trying to connect to. So this is not really a big deal for us at the moment. Just know that this is something that happens because SSH is trying to make sure that it knows the remote target you're connecting to. And by accepting, by typing yes here, it will create an entry in the file SSH known hosts. And the next time you're going to connect to that IP address, SSH is going to make sure that the host didn't change keys. So this is usually a good thing for security in our case, because we're going to create instances, terminate instances, their host keys are going to change. So this is something that we'll have to fix a little bit later. For the moment, you can just go ahead and say yes, and then you'll be good and you'll have access to your instance. So this is your AWS instance. It's basically running Ubuntu Linux version 20 LTS, so that's good. It has a private IP address in our VPC, and thanks to our routing tables and whatnot, we have access to the internet. We can ping, result.com. Yeah, it does ping. And obviously, we have SSH access to the instance because we just connected using SSH. So our elastic/public IP stuff works as well. And if everything went fine, we should also have sudo access. So that went a little bit too quick for my taste. But sudo is a program or binary that allows you to run administrative tasks without knowing the root password, which is good for security. This is Ubuntu, so you would probably want to do apt updates in order to update your list of repository, your list of packages based on the repositories. You cannot run that as a regular user because it's an administrative command. So you can do sudo apt update, and now you can do whatever you want. So for instance, we are going to upgrade everything, all the packages on our instance, which is probably going to take a bit of time. Let's do it anyway. Okay, that was fast. And well, this is happening. So we are doing apt upgrade. So that is after I've done apt update, which updated my list of packages, I run apt upgrade, which is now downloading and unpacking and installing any updates that would be available on my Linux system. This is going to take some time, I'm afraid. Generating the modules. This is where you may want to have more than 1 gig of RAM and 1 CPU on your instance. But we're almost there. All right, good stuff. That was not really necessary to update the kernel, but anyway. So yeah, so we have updated everything on our instance. We can run administrative commands on the machine using sudo without using a password. So that's good. And basically, yeah, for instance, something that we are going to do a little bit later is to install a web server on that machine. We are going to use Nginx for that. Nginx comes packaged in the Ubuntu distribution repositories. So we can just apt install Nginx. Yes. So now it's installing Nginx from the repositories. And we are going to expand on that much more next week. But now, basically, Nginx is set up and installed. So you can have a look at what's happening on the services side. Well, Nginx is active and running. That's awesome. It's enabled. Yeah, it's enabled here. So anytime our instances is going to start, Nginx is going to start as well. And if we've done everything right, because Nginx is running, we can access our instance using a web browser. So let's do that. Let's change screens. Go there. Yes. So this is my instance, and it's now running Nginx, which means that if I open that IP in my browser, I can see a web page. So this is the web page that is served by my instance running on AWS, and it says, welcome to Nginx. And if you would like to make sure that this is actually what's happening, you can make some changes here and change the HTML file. Sorry, you didn't see that because I was not sharing the right screen. So basically, this is the index.html that sits in /usr/nginx/share/nginx/html. And this is the file that is served by Nginx when you hit the home page. So if I make some changes to that file and I change my screen sharing, go back to my browser. That didn't work. I think my browser is caching the page. All right, yeah. So after a little bit of investigation, it happens that I was not changing the correct file. So the file that you need to change on this Ubuntu version of Nginx is actually located in /var/3w/html, and it has a very funny name, index.nginx-debian.html. So I'm just going to change that file now. Pretty big fail. And I changed the file. And now I can refresh the page in my browser. And it says it works because this is what I wrote in my index.html file. All right. So this is everything that we wanted for this week. Set up your AWS account. Make sure you have credits or your credit card linked to your account. Set up your VPC, your subnets, your security groups, etc., etc. We will work with SSH connections, Nginx, and all that more in details next week. So don't freak out about that yet. And once you're done with everything you wanted to do on your instance, you can terminate the instance in order to stop being charged for it. So on your dashboard, EC2 dashboard, you can basically just go ahead and go to terminate instance. You don't want to stop the instance. If you stop the instance, it will, well, stop, but you will keep being charged for it. So this is not the best. You want to terminate the instance, and when you terminate the instance, Amazon is going to tell you that it's going to delete your storage space as well, and it's going to delete your public IP address. If you set these up in a separate step, and AWS does not delete them for you, if they are not linked to an EC2 as instance that's active, you are going to be charged for them too. So make sure that you have deleted your EBS and Elastic IP if you set these up separately. Now I can do terminate, and everything that I have just done is being lost forever because I terminated my instance. So basically, I destroyed my instance, which means that if I ever recreate a new instance, it will have a new IP address, it will have a fresh state, no packages installed, no upgrades done, etc., etc. Which means that I'll have to redo that work over and over again. But the whole concept of this class is to see how we can make that not repetitive, so that we can run scripts and we can automate the setup of the operating system and the machine, so that we don't have to do everything manually every time. Okay, so now my instance is terminated. You can see it here. It will still show up in the list, but you will not be charged for it. And basically, it's terminated. I think it disappears after 10 or 15 minutes. If you go to your EC2 dashboard, you will see that you have no instances running. I have 0 here. So that means that I'm good in terms of actual charges. Okay, that's it for today. Thank you for listening, and I'll see you all next week.